So some of the basic probability concepts would be independent events. Now, an independent event is when the probability of occurrence of any event does not affect the probability of the occurrence of another event. Then the two events are said to be independent. Then we have dependent events. This is when the probability of one event occurring will influence the likelihood of the other event. So these events are said to be dependent. Then we have mutually exclusive events. This is when an event is said to be mutually exclusive if the occurrence of any one of them prevents the occurrence of all the others. And then finally, there are mutually inclusive events. This is where any two events wherein one event cannot occur without the other, which are said to be mutually inclusive events. So when we look at multiplication rules or AND rules, multiplication rules and AND rules depend on event dependency. So if events are independent, for example, A is independent of B and C is independent of A and B, those are considered independent. Now, special multiplication rules can be applied. So, for instance, let's look at this. Let's say that we're trying to figure the probability of an occurrence of all of the following events. When we flip a coin, we get heads. When we draw a card, we get an ace. And when we throw a dice, we get a 1. Now, all of those events are independent, right? Because they all have different probabilities of getting what we want. So, for instance, in heads, it's going to be 50%. When we get to draw an ace out of a card, it's going to be 1 out of 13 possibilities because we go face card all the way to 1 ace to 10, right? And then on top of that, when we're looking at a die, there's only 6 possible opportunities because it only goes to 1.6 or 1 to 6. So let's figure this out. So it looks like this. So to find the probability, we have to multiply all of these together. So we have A, and then we have and B, and we have A and C. So that's kind of what our algebraic expression looks like up front. Now we can break this down further. So first off, we have probability of A, right? Multiplied by the probability of B, and multiplied that by the probability of C. So the A is going to be our coins, B is our cards, and C is going to be our die. So then what's the opportunity for us to get what we want? Well, with a coin, there's only 2 possible options. It's heads and tails. With a coin or with cards, there's 13, and with a die, there's 6. But we're only wanting one thing, right? We only want to get a head out of our coin, so it's going to be 1. And we want to find an ace, which is only one of those out of 13 possible, so that's going to be 1. And then we want to get a 1 when we roll our die. So then we have to multiply all of these together. So 1/2 times 1/13 times 1/6 is going to give us something like 0.0064, which is 0.64%. So the probability of us flipping a coin and getting heads, getting an ace out of our deck or out of our cards, and then rolling a 1 on a die is 0.64% probability that that could happen. And that's the multiplication and the AND rule. So in the previous example, we said, well, what happens if those events are independent of each other? Well, now what happens if they're dependent of each other, where A is dependent upon B, and there's only those 2 dependent events? Well, let's look at this example. Let's say that we have a bag that contains 6 golden coins and 4 silver coins. 2 coins are drawn without replacement from the bag. What is the probability that both of those coins are silver? Well, our calculation looks a little bit different, right? So the first thing that we have to do is look at the 6 and the 4 coins. So 6 over 4, or 6 plus 4 is 10. So we know that there's 10 coins within the bag. Now we also know that 4 of those coins are silver. So it begins immediately with 4 over 10. But then we also have to look at the fact that if we're drawing out 2 coins, both of those coins have the probability of being silver. One of those coins have the probability of being silver, and none of those coins have the probability of being silver. So we have to do some assumption. And so then what it comes down to is a calculation that looks like this. So it's BA, which then gives us this calculation of 3 over 9. So it begins with 4 over 10 because we're going to take one of those away, which gives us the 3 over 9. So when we start doing our calculations, it looks like this. 4 times 10, or 4 over 10, 3 over 9. We do our math. That's 12 over 90 because we're just multiplying straight across. And then we do our math this way. So it comes out to be 13.34%. Sorry, that looks like an 8. So we know 12 over 90, do our math, there's a 13.34% probability that both the coins pulled will be silver. And that's how we calculate it, multiplication rules and rules when the events are dependent upon each other. So let's talk about permutation and combination. So here are the definitions. Permutation is just defined as the total number of ways in which a set, group, or number of things can be arranged, while combination is the unordered arrangement of a set, group, or a number of things. So let's talk about calculating permutation and combination. Let's say that we're sitting in a poker game and we really want to understand how the best way to arrange our cards in our hands are. So let's say that we were dealt a poker hand of an ace of spades, a 7 of clubs, a 7 of diamonds, a jack of hearts, and a 2 of clubs. Now, permutation is talking about the multiple different ways that we can arrange our cards. So the first thing that we need to do is we need to have a mental kind of box for each one of our cards. We'll just call it a blank box. Now we have 5 cards. And so if we place the ace in the first card, we have 5 opportunities to place any card in that box. So I'm going to place the ace of spades there. Now I only have 4 cards left. So out of the 4 cards that I have left in my hand, I only have 4 possible spaces to place that. So I'm going to take my 7 and I'm going to place it there. Then I have 3, and then I have 2, and then I have 1 for each one of the cards. So when we start to calculate permutation, we start with, we had 5 original options to place our cards. Multiply that by 4, 3, 2, and 1. So as we start working our way through that, we can come up with 120. So there's 120 possible combinations to put our card, or 120 possible permutations to do our cards. Now, something to gather when we're talking about permutations is this thing called a factorial, or a factorial. And what that's talking about is that there's 5 possible, there's only 5 possible blocks. And so the factorial that we use is 5 with an exclamation point. So the 5 factorial is equal to 5 times 4 times 3 times 2 times 1, which is equal to 120. And that's how you calculate permutation and combination.